Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that a single phase 500 volt by 100 volt 50 Hz transformer has a maximum core flux density of 1.5 Weber per meter square and an effective core cross-sectional area of 50 centimeters square. Determine the number of primary and secondary turns. Solution. Now, the area is given by 50 centimeters square, which if you convert to meter, it becomes 50 times 10 to the power of minus 4 meter square. So now this voltage, usually the first voltage they write in this format is the primary voltage and the second one is the secondary voltage. So here the primary V1 is the primary is 500 volts, then V2 is 100 volts. This is primary voltage V1 and secondary voltage V2. Then the frequency is 50 Hz. So F is 50 Hz. Then the maximum core flux density of 1.5 Weber per meter square is given by Bm. This is B subscript M. Then is 1.5 Weber per meter square. Then now we need to find, this is the maximum core flux density. We need to find the maximum flux. So the maximum flux is given by this times the area. So this is what? This is 1.5 Weber per meter square times this area in meter square. So that meter square and meter square will cancel. 50 times 10 to the power minus 4. 1.5 times 50 times 10 to the power of minus 4. This is what? This is 7.5 times 10 to the power of minus 3. So it is 0.0075 Weber. That is 7.5 times 10 to the power of minus 3. Then we will use the formula V1 is equals to 4.44 F N1. So this one, the formula, you can use V1 for voltage or E1 for EMF. They are the same thing. So now we'll make N1 the subject of the formula. N1 is what? V1 over 4.44 F times this. So this becomes what? What's V1? What is V1? Is 500 over 4.44 times what is F, the frequency, is 50 times this is 0.0075. Five hundred 4.44 times 50 times 0.0075. This is 300.3. 300.3. So this is 300.3. So since we are finding number of turns, it has to be a whole number. So we'll approximately round this to 300 turns. So N1 is 300 turns. Then to find N2, we'll use the same formula, but with a little difference. N2 is now equals to what? V2 over 4.44. This is the secondary number of secondary turns. This is the number of primary turns. So the number of primary turns is 300 turns. Now we'll find the number of secondary turns. And we'll use the secondary voltage, which is 100 over 4.44 times 50 times 0.0075. So this is 60.1, but which is approximately 60. So this is approximately 60 tons. So the number of primary tons is 300 and the number of secondary tons is 60. So that is all. So this is how to find the number of primary and secondary tons in a transformer. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.